Hello students, how are you all? I hope you all are fine. This is your chemistry lecture of grade 9th, and I am your chemistry teacher Aparna Pandey from Art and Progressive School, Lamachar. So student, as you all know that we are discussing our chapter number 1 and the name of our chapter is Matter in Our Surrounding. So student, here in this chapter we have discussed about the physical nature of matter as well as the characteristics of matter, and with the characteristics I have also explained you some activities that are related to the characteristics, the activities that are telling us about the characteristics of particles of matter. These all things we have discussed in our previous video. Now student, in today's class, as in previous video, I have ended up by dividing the states of matter into the 5 parts, and then I told you that the rest part I'll explain you in the next video. So, I hope you all have attended the Google Meet, and there we have discussed very nicely about the properties of the states of matter. But let's have one revision again, because those who have not attended, they can go through this video and they will clearly get the idea about the different properties of states of matter. Sorry. So as you all know that we have mainly 5 states of matter. Okay. This I told you earlier also, when we talk about the states of matter. When we talk about the states of matter, I have made earlier also there is a division. It can be divided into the 5 types. 1, 2, 3, 4 and 5. And what type of division it is? It is solids, liquid, gas, plasma and Bose-Einstein Condensate. Okay, this is nothing is new for you. These 5 states I have already explained in my previous video. Okay, about solid, liquid, gas, plasma and Bose-Einstein Condensate. So student, now in today's class, what we have to do here, we will study according to the molecular structure. As there also I have shown you about the molecular structure of solids I have shown, of liquids also I have shown, and of gas also I have shown, right? And in Google Meet also I have explained you the properties of plasma as well as Bose-Einstein Condensate. So when we talk about the solids, you all know that the molecular arrangement in solids is very tightly packed. The molecules in the solids are very tightly packed. Okay, you all know this. In solids, molecules are arranged like this, right? When we talk about the liquids, in liquid the molecular arrangement is like this, where molecules are arranged, they are not so tightly packed as compared to solids, right? Molecules are there, but they are not so tightly packed as in solids. Means you can see that in liquids the molecule has some space, and when we talk about the gas, we can see here that the molecules are free to move. When we talk about the gas, the molecules are free to move. So these 3 types of structure I have also shown you in previous video. Now students, what we have to do today, we have to just discuss the properties by watching these, or by considering the structure of solid, liquid, gas, and by considering that how molecules are packed here. So when we talk about the solid, or when we talk about the solids, what we can say, if we say about the shape and volume, okay, let's divide them like this. Then further we will see later on. Okay. So when we say about the solids and when we talk about the shape, what we can say in solids, when we say shape. So what we will come to know that solids have fixed shape. This you all know. Solids have fixed shape right? Solids have fixed shape. When we talk about the liquid do not have fixed shape. Okay, so not fixed shape, but we can write here not fixed shape. Not fixed shape. When we talk about the gas, they also do not have fixed shape. Not fixed shape. Okay, F-I-X-E-D. Not fixed shape. So nothing is new there. This you all know about the shape of the solid, liquid and gas. That solids have fixed shape, liquid do not have fixed shape, and when we talk about the gases also do not have fixed shape. Then in terms of volume, when we talk in terms of volume, what we can say, in terms of volume we can say that in solids, what do you think? When if we put some solid object from one place to another, then what do you think? The shape or the quantity of that solids change? No, it does not. It means that the volume of the solids remain fixed. So what we will say in the case of volume, that in solids volume is also fixed. We can say here in solids the volume is fixed. Now what do you think about the liquids? When we talk in the case of volume about the liquid, I explained to you earlier also that suppose we have taken 1 liter milk. So it doesn't mean that if we are pouring that 1 liter milk in 5 liter container, so the milk will also become 5 liter? No, it is not possible. Means the volume of the liquids will remain as it is. The quantity never increases according to the container. Okay, the quantity not increases according to the container. So what we can say in liquid is also volume is fixed. Suppose in you have one bucket and you have filled that bucket completely. Suppose the capacity of the bucket is to hold 3 liter water. Now you are pouring that 3 liter water in 10 liters. So it doesn't mean that 10 liter container will fill completely. No. Why? Because the liquid that you have taken, its property is that it makes its volume fixed. So either you are putting it in 10 liter or you are putting it in 5 liter, but the quantity of the liquid will remain 3 liter only. So from here it is also clear that volume is fixed in liquid. So what we can say, volume is fixed. Volume is fixed in liquid. When we talk about the gas, now what about the gas? You know that if we want to fill a gas in a small balloon, we can fill it, and you know that the whole space is covered by the gas. Similarly, if we want to fill that gas in a cylinder, yes, then we are able to fill the cylinder with the gas, and definitely the cylinder will be filled completely. So what it is so? It is so that when we are shifting the gas of a small balloon into a cylinder or from a cylinder into a balloon, then what we are getting? We are getting that yes, gas has a capacity to change its volume. Gas has a capacity to change its volume because in gas, earlier the gas was in big container, but now when we have changed the size of the container, still it is able to fill gas in it completely. So what it is? It is that the gas can change its volume according to the container we are changing, right? So from here we can say that yes, gas do not have fixed shape. Sorry, fixed volume. Gases do not have fixed shape, as well as gases do not have fixed volume. Not have fixed volume. Okay, so here from here two properties are clear. Not have fixed volume. And you know about the shape also, that gases do not have fixed shape because you are filling the same gas in a round balloon, you are filling the same gas in a hard balloon, and you are filling the same gas in a teddy bear shaped balloon. So everywhere balloon are filled completely, means that gases do not have their any own shape. They occupy the shape of the container, and the same thing happens with the liquids also. If you are pouring the liquid in a glass, it will definitely take the shape of the glass. If we are pouring that into a ball, it will definitely take the shape of the ball. So these are the things related to the shape and volume. Okay. Now suppose we have to consider the intermolecular space. Suppose we have to consider intermolecular space. Okay. So let me write here intermolecular space. When we consider about the intermolecular space, intermolecular space. When we talk about the intermolecular space, let's see in terms of solids, liquids and gas. So in solids, what do you think that do they have intermolecular space? What is intermolecular? Molecular means molecules, inter means in the molecules. So what do you think that here the solids have any type of intermolecular space? No. Solids do not have intermolecular space. Okay. So what we can say? No intermolecular space. We can say that no intermolecular space. No intermolecular space. When we see the liquids, then in liquid we can see the arrangement of the molecules and we can find here very easily that yes, there is a little space between the molecules. So what is this? This space, yes. Liquids have intermolecular space. Okay, but we can say liquids have intermolecular space, less intermolecular space. Yes, liquids have. Like solids, in solids there is no intermolecular space, but when we talk about the liquids, yes, liquids have intermolecular space, but we can say very less intermolecular space. It is not very much. And when we talk about the gases, though I have made very much molecules, you can do like this also. So like this, there are number of molecules. So what we can see, in case of intermolecular space, gases have very much intermolecular space. So we can say that yes, have large intermolecular, have large, or we can say much intermolecular space. Intermolecular space. This we can say about the gases. Here we can see the molecular arrangement and then we can say that yes, gases have large intermolecular space. So I hope now students it is clear to you that what we are talking about. We are talking about the space between the molecules, and what we found that there is no space between the molecules of the solids. When we talk about liquid, yes, they have little space, and when we talk about the gases have enough space between them. Gases molecules have enough space between them. Now, here we have done conversation about the intermolecular space. Let's see what is the intermolecular force. So, when we talk about the intermolecular force, as we have seen the case about the space, let's talk about the force. So, where the space is less, there is the force of attraction is more, because intermolecular force, or we can say force of attraction, we also know it by the name force of attraction. So when we talk about the force of attraction, what we come to know that intermolecular force or force of attraction, so in terms of solids, what we see that in terms of solids, yes, solids have very much force of attraction. Solids have very much force of attraction, means we can say high force of attraction. High force of attraction. Why it is so? High force of attraction. Why it is so? This is only the reason that molecules are so tightly packed, because they are attracted towards each other very strongly. When we talk about the liquids, when we talk about the liquids, then what we find that yes, liquids also have intermolecular force of attraction. Yes, of course, liquid molecules also have force of attraction, but it is quite less as compared to solids. It is the force of attraction attraction is most in the solids, then little less in the liquid and least in the gas. Okay, less force of attraction as compared to solids. So what we can say? Less force of attraction, less force of attraction. And when we talk about the gases, what we can say? No force of attraction, no force of attraction, no force of attraction. So how we are saying this? We are saying this because when we see in solids molecules are tightly packed, so means they are attracted very tightly. When we say liquid, yes, they have force of attraction but not as compared to solids, because yes, liquid have little bit fluidity, they have little flow, and this is the reason because there the molecules are not so tightly packed like solid. And when we talk about the gas, so we can say very easily that no, they do not have any force of attraction. Okay. So I hope from here intermolecular force of attraction as well as intermolecular space, both the things are clear to everyone. Now when we talk about the rigidity, what do you think? When we compare solid, liquid and gas, what do you think? Which state of matter has the most rigidity and which is having the least rigidity? So rigidity means the solidness, the tightness. So for that we can say that solid are most rigid. Then liquid do not have rigidity because they comes under the category of the fluidity. Liquids have fluidity, and yes, gases are mostly fluid because gases can flow very easily. Okay, rigid means the tightness. So tightness is very much in solids, then little less in liquid, and then gases do not have any type of rigidity. When we talk about the fluidity, fluidity means flow. Fluidity means flow. So solids do not have any type of fluidity. Okay, solids do not have fluidity. And yes, liquids have fluidity, but the most fluidity is with the gases. Okay. Now, when we talk about the density, then what do you think that which is the most dense? Which is the most dense? See, when we talk about density, what we see that when we talk about the density, we know that density means mass per volume. Mass per volume. So when we see solids, what we see that mass in volume, here the volume as well as the mass both have almost equalization there. So we can say the most dense is solids. The most dense is solids. Here you can count the number of particles. You will find absolutely more as compared to liquid. Liquid are little dense as compared to solids because here we can say space is there, and very least dense then we can say gas. So when we compare the state of matter, solid, liquid and gas in terms of density, then what we found that solids are most dense, then liquid are dense, but they are little less dense as compared to solids, and gases do not have density. Gases are least dense we can say. Do not have density we will not say, means gases have very least density as compared to the two states of matter. Okay. Now, when we talk about the compressibility, students, then you know that, what do you think? Is it which these are the three states of matter, which one we will able to compress? Which one we will able to compress? So this we find that as here number of particles are more, they do not have any space, force of attraction is very more, rigidity is most. It means that compressibility will be very less or not compressible. But we can say that solids are not compressible. Solids are not compressible. Okay. When we talk about the liquid, but we will say yes, liquid are also, we can say liquid are also not compressible, but They have negligible compressibility. Why we are adding word negligible here? Because they have a very little compressibility when we compare it with the solids. Because we cannot compress solid, but when we see the compressibility in terms of liquid, yes, minutely we can compress. So that's why we were saying compressibility in solids is negligible compressibility, and gases are mostly compressible. Most compressible. Gases are most compressible. So I hope when we talk about the terms of the kinetic energy, now you know kinetic energy depends upon the motion of the particles, and when we have studied the characteristics and the particle nature of matter, we come to know that in matter particles always move. Okay, so what we can say, there is a movement of particle in liquid, there is a movement of particle in gas, but when we talk about the solid, the particles vibrate in solid because movement is not possible, so vibration is there. Okay, now I told you earlier that motion is related to kinetic energy. So what we can say, that kinetic energy, because in solid motion is not there, only a vibration. So in terms of kinetic energy, the least kinetic energy is of solids. And when we say liquid, yes, liquid have kinetic energy, and the most high kinetic energy is of gases. I hope. See beta, these all things we have already discussed in previous video, but again I have just made revision of that. So I hope it is clear to everyone when we have talked about the solid, liquid and gas. Now here we are going to discuss about the plasma and Bose-Einstein condensate. So when we talk about the plasma, plasma is a state where we can say when gas is superheated. When gas is superheated, then it gets changes into ions. It gets changes into ions. The gas when heated most, it gets changes into ions. Gas become ionized, and that ionized gas, the ions are super excited. The ions are super energetic. So that state where gas becomes super ionized, super excited, overheated, then it changes into plasma. Then it changes into the plasma. Okay, like we have, I hope that you all have seen the CFC bulbs, tube lights. Okay, LED. So what is there? You have seen that they gives us the colorful light. How? Because they are filled with the different types of gases, like inert gases like neon, argon, and these gases have color. Like neon have red color, argon have green or yellow color. So when we pass current in these inert gases, what happens that the molecules of these gases start ionizing, and when they start ionizing, because they are in super excited, super energetic state, so they start emitting light. Okay, they start emitting light. This is the stage of plasma. Super ionized, super excited, super energetic. Okay, this is the state of plasma. Now when we talk about the Bose-Einstein condensate, when we talk about the Bose-Einstein condensate, then we can say that it is just opposite of plasma. Why we are saying just opposite of plasma here? Because in Bose-Einstein condensate, what happens that the gas is super cool. The gas is super cool here. Super cool. So when we are doing cooling of the gas to extremely low temperature, when we are doing cooling of gas to extremely low temperature, then what is happening here? That the molecules are coming close to each other. The molecules are coming close to each other, and they come so much close that they lose their identity and they just become a one. they just become a one property, they just become a one identity, we can say. Every molecule lose their individual identity and they just become a one particular matter, one particular mass. And how it is possible? It is possible because here is when we have super cooled the gas, so the matter becomes so much hard that it is harder than the solid. It is harder than the solids. So this is the state of the Bose-Einstein condensate. Okay, this is the Bose-Einstein condensate state where the molecules of the gas are super cool, and due to that super cooling they come together, they become very close, they lose their individual identity, they become a one mass, and they become much harder than the solids. So these are the students 5 states of matter: solid, liquid, gas, plasma and Bose-Einstein condensate. Now it's time to discuss about the temperature. So do you know what is the meaning of temperature? When we talk about the temperature, what do you mean by temperature? What is temperature? Temperature is the measure of the hotness or coldness of a particular body. Okay? When we talk about the temperature, what we say? Temperature is the measurement of hotness or coldness of a particular body. Body doesn't mean the human body only, it can be anything. Okay, so when we measure about the hotness and the coldness of the particular body, then we are saying that this is temperature, and we can measure temperature with the help of the thermometer. You all know this, that we can measure temperature with the help of the thermometer. Now, when we talk about the temperature, students, so I hope that you have heard about the Kelvin scale, Celsius scale, Fahrenheit scale. So what are these? These also we will discuss here. So first of all, temperature means the measurement of the coldness or the hotness of a particular body, and we can measure temperature with the help of the thermometer. Now, when we talk about the different scales, because when we have to measure temperature, we need a scale. For measuring temperature, we need a scale. Okay. So when we talk about the scale, so we can say that we have 3 different types of scale, right? What are these? We have Kelvin scale, we have Celsius scale, we have Kelvin scale, we have Fahrenheit scale. Okay, but we call it degree Celsius, degree Kelvin, degree Fahrenheit. Okay, these are the different scales: degree Celsius, degree Kelvin and degree Fahrenheit. Now students, when we talk about these scales, you must know that every scale has one lower value and one, we can say, upper value. Okay, but it is called, wait, let me tell you, we can say lower, every scale has one lower fixed value and upper fixed value. Okay, every scale has one lower fixed value and one upper fixed value. What is this lower fixed value? Lower fixed value means the least temperature, and you know, when we say about the least temperature, we are talking about the freezing point. We are talking about the freezing point. And when we say about the upper temperature, we are talking about the boiling point. Okay, so what we are saying that, when I told you that if every scale has one lower fixed value and we can say upper fixed value. Every scale has lower fixed value and upper fixed value. What do you mean by lower fixed value? Lower fixed value means boiling point. Lower fixed value means boiling point. And when we say about the upper fixed value, then upper fixed value means I think I have written wrong. Lower fixed value means freezing point. Lower fixed value means freezing point, because the lowest temperature, it will cool the thing it is a freezing point, and when we talk about the upper fixed value, so it will increase the temperature, so it is boiling point. Okay, first you must know this, that every scale has its lower fixed value and upper fixed value. Now let's talk about the lower fixed value and upper fixed value of degree Celsius, degree Kelvin and degree Fahrenheit. Okay, so what do you think that which value we will take as a lower and the upper in the degree Celsius? So when we say about the degree Celsius, it is from 0 degree Celsius to 100 degree Celsius. Okay, it is from 0 degree Celsius to 100. When we say, see this 0, this is 0 degree Celsius to 100 degree Celsius. When we talk about the degree Celsius, it has two values, lower fixed and upper fixed, and these are 0 degree Celsius to 100 degree Celsius. When we talk about the Kelvin, when we talk about the Kelvin scale, then its lower fixed value is 273 degree Kelvin, 273 degree Kelvin to, we can say, 373 degree Kelvin. Okay, then it has the value to 273 degree Kelvin to 373 degree Kelvin. And when we talk about the Fahrenheit, then what value Fahrenheit has? So Fahrenheit has 32 degree Fahrenheit to 32 degree Fahrenheit to 212 degree Fahrenheit, 212 degree Fahrenheit. Okay, what we have seen here? We have seen here that for measuring temperature we have different scales. These are Celsius scale, Kelvin scale, Fahrenheit scale. Every scale has two fixed points. One is lower fixed value and other one is upper fixed value. The lower fixed value is called freezing point and the upper fixed value is called boiling point. And when we see degree Celsius, then we come to know that degree Celsius had its lower fixed point 0 degree Celsius, upper fixed point 100 degree Celsius. When we talk about the Kelvin, we come to know that it has lower fixed point 273 degree Kelvin and upper fixed point 373 degree Kelvin. When we talk about the Fahrenheit, we come to know that it has lower fixed point 32 degree Fahrenheit and upper fixed point 212 degree Fahrenheit. So this we have discussed about the temperature scale. Now, when we say about the temperature scale, we have one more concept that is called absolute Kelvin temperature. It is called absolute Kelvin temperature. We have one scale that is called absolute Kelvin scale, and the temperature we measure there, it is called the absolute Kelvin temperature. So we will write here absolute Kelvin scale. What it is? The scale where we measure the absolute Kelvin temperature. It is called absolute Kelvin scale, where the lowest temperature is 0. Okay, this is absolute Kelvin temperature. It is the temperature which is measured by the absolute Kelvin scale, and here in absolute Kelvin scale, the lowest temperature is 0 degree Kelvin. The lowest temperature is 0 degree Kelvin. Now what you have to keep in your mind, that when we are talking absolute Kelvin, then we are saying that Kelvin scale has lowest temperature 0 degree Kelvin. But when we are talking about the lower fixed value and upper fixed value of the Kelvin, then we are saying that lower fixed value is 273 degree Kelvin and upper fixed value is 373 degree Kelvin. Okay. Now, when we say absolute Kelvin, then we will say that in absolute Kelvin scale, the lowest temperature is 0 degree Kelvin. Okay. Then we have, I think, now when it comes about the We also have the absolute temperature of degree Celsius as well as degree Fahrenheit. So I don't think that it is in your syllabus, but when we talk about absolute Kelvin, so I must tell you about the absolute Celsius and absolute Fahrenheit. So when we talk about the absolute Celsius temperature, then what we say how much it is. When we talk about the absolute Celsius temperature, it is minus 273 degrees Celsius. Okay, then it is minus 273 degrees Celsius when we are talking about the Celsius scale. And when we are talking about the Fahrenheit scale, when we are talking about the absolute Fahrenheit temperature, then what we will say that it is minus 460. Then it is minus 460. Minus 460 degree Fahrenheit, or you can say minus 460. So what we have noticed here, about the fixed lower value and fixed upper value, and then I told you that there is one absolute Kelvin scale where the temperature goes much low, and then we call it absolute scale. So in terms of absolute Kelvin scale, the lowest temperature is 0 degree Kelvin. When we talk about the absolute Celsius temperature, then it goes minus 273 degrees Celsius, and when we talk about the absolute degree Fahrenheit temperature, then it goes down to minus 460 degree Fahrenheit. But the most that you have to remember is this one. Okay, now there is also a relation between degree Celsius and degree Kelvin. So when suppose it is asked you to change between the Kelvin and Celsius, so how you will do that? So for that, student, there is one formula, or we can say a relation between the degree Fahrenheit and, sorry, not degree Fahrenheit, degree Kelvin and degree Celsius. So when we talk about the relation between degree Celsius and degree Kelvin, then what we will say that it is when we have to change Kelvin into the Celsius, then when we have to change Celsius into the Kelvin, then what we will do, we will write degree Celsius plus 273, but we will write degree Celsius plus 273 means when the value of degree Celsius is given and it is asked that change the given degree Celsius into degree Kelvin, then which formula you will apply? You will apply this formula, that degree Kelvin is equals to degree Celsius plus 273. And when it is said that you have to change degree Kelvin into degree Celsius, means when degree Kelvin is given and you have to change then in degree Celsius, then what you will do? You will write there Kelvin minus 273. What you will write? Kelvin minus 273. So these are the formula, or we can say this is the relation between the Kelvin and the Celsius. This we relate both Kelvin and Celsius by taking this one 273. When we have to find Kelvin, we are adding 273 in Celsius. When we have to change Kelvin into Celsius, then we are subtracting 273 from it. Okay. So in this way we can find the relation between the degree Celsius and degree Kelvin. So students, here today we have discussed about the temperature as well as the properties of the solid, liquid and gas. Now for interconversion of states, I think that we must discuss that in another video. Either video will also become very long and it will become quite tough for you to understanding so many topics together. So I hope that you all will like this video. Thank you and have a nice day ahead.